Belting made easy.
Welcome to our journey through the process of scrap recycling. From initial shredding to sorting and final separation, every step is designed to maximize resource recovery while reducing waste. Let's explore each stage in detail. Our journey begins with large scrap materials like cars and appliances being loaded onto an in-feed conveyor. This conveyor moves the scrap into the shredder. The hammer mill or shredder has powerful blades that reduce bulky metal into fragments, making the material easier to sort and process in the next stages. Once shredded, the material is moved into the trommel, a rotating cylindrical screen. Here, finer particles are separated from larger pieces based on size, helping prepare each type of material for specialized sorting. First, the finer particles fall through the smallest mesh opening. As the particles move forward in the trommel, the opening of the mesh increases in size to separate medium and larger sized particles. The biggest particles at the end get discarded to be run through the shredder again. The medium-sized particles keep moving forward on the conveyor belt in the middle for further separation. The smaller particles move to the flow screen, where a vibrating plastic screen performs additional separation. All the transfer belts in scrap recycling are usually made from black rubber, and they have bonded cleats or a molded cleat pattern on the cover. Rubber offers good abrasion resistance and cost, as well as good resistance to the elements, which could be important if part of this process is done outdoors. This step refines the separation achieved by the trommel, dividing the smaller materials into fine and very fine sizes. Like the trommel, a mesh with different size openings vibrates to allow the materials to move down and to fall through one side or the other. Now we have very fine, small, and medium-sized particles moving on to the next stage on 3 separate conveyors. Our material encounters the cross-magnetic separators. These conveyors contain powerful magnets inside that attract and remove ferrous metals like iron and steel. Each separator magnet is calibrated based on the size of the particle to separate. The end of the cross conveyors is not magnetized, and so the ferrous metals are dropped onto the dedicated conveyor belt below. Thanks to this process, every ferrous metal gets separated from the stream in a different pile. The cross-magnetic separator belts need to be high abrasion resistant and impact resistant to have a long life. Most people use either red or clear polyurethane belts with a very thick and hard cover. Other companies use black rubber belts with metal plates. Small and fine particles are mixed together again, and now we have two conveyors moving to the air classifiers with small and medium-sized particles. Using strong air jets, these classifiers separate materials based on weight. Lighter particles like plastic, woven and non-woven fabrics are carried up and out of the stream, while heavier materials continue to the next stage. Finally, we reach the three-layer eddy current separators. These advanced systems use the Foucault or eddy current to create magnetic fields that repel non-ferrous metals, such as aluminum and copper, from the remaining scrap. The eddy current belts need to have a good balance between abrasion resistance and thickness. The thicker the belt, the harder it is to separate small-size metals. In terms of cost, these belts can be made of standard green PVC as the most economical option, or of thicker and harder polyurethane in green, black, clear, or red color. The belts usually have an edge sidewall to prevent the product from falling off the sides. Because these belts move at great speeds, as high as 4 meters per second or 800 feet per minute, they also need top-edge V-guides to help with tracking. Non-ferrous metals get ejected and fall onto the conveyor belt below, while the rest of the scrap continues onto the next eddy current separator. The three-layer setup allows for progressive separation, where the machines are calibrated to separate particles by size, ensuring that even the smallest valuable fragments are recovered. The remaining unseparated particles will go to the landfill. Through this complex yet efficient process, we recover valuable materials from scrap, ready to be repurposed. By maximizing the recycling of metals, we reduce the need for new resources and contribute to a more sustainable future. Thank you for joining us on this journey through the scrap recycling process. By supporting recycling, we can all play a role in preserving our planet's resources.